In previous video, we have seen practice problems on relations and functions. In this video, we will cover few more problems on relations and functions, specifically on functions, algebra of functions and types of functions. Problems based on functions. Let a is equal to -2, -1, 0, 1 and 2, and it's given as function f from a to z be a function defined as f of x is equal to x square minus 2x minus 3. Find range of function f of a and pre-image of 6 minus 3 and minus 5. Now it's given as f of x is equal to x square minus 2x minus 3. So we will calculate the value of f of x for its domain. So f of minus 2 is equal to minus 2 square minus 2 into minus 2 minus 3. So ultimately what we are doing is we are putting minus 2 in place of x. So after simplification we will get 4 plus 4 minus 3, that is equal to 5. Similarly, f of minus 1 is equal to minus 1 square minus 2 into minus 1 minus 3, that is 1 plus 2 minus 3 is equal to 0. F of 0 is equal to 0 square minus 2 into z minus 3, that is 0 minus 0 or plus 0. 0 minus 0 minus 3, that is equal to f of 1 is equal to 1 square minus 2 into 1 minus 3, that is 1 minus 2 minus 3, which is equal to minus 4, and the last element is f of 2 is equal to 2 square minus 2 into 2 minus 3, that is 4 minus 4 minus 3, which is equal to minus 3. So what is range of the function? Range of the function will be minus 3, minus 4 and 5. So if we write in the form in ascending order, range would be minus 4, minus 3, 0 and 5. Now we need to find out pre-image of this function for 6, minus 3 and 5. Now f of x is given as f of x is equal to x square minus 2x minus 3. So we need to find out pre-image for 6. That means we need to calculate value of x for which the function f of x will return the value as 6. So x square minus 2x minus 3 is equal to 6. Now if we rearrange this equation, then we'll get x square minus 2x minus 9 is equal to 0. Now we cannot find out factors of 9 which gives us summation as minus 2. Hence, in order to find out the value of x, we will use the formula. So by this formula, x is equal to minus b plus or minus under root b square minus 4ac upon 2a, where a is equal to plus 1, b is equal to minus 2 and c is equal to minus 9. So by putting the values, we can find out the value of x as x is equal to 2 plus or minus minus 2 bracket square minus 4 into 1 into minus 9 upon 2 into 1, that is 2 plus or minus under root 40 upon 2. Now we can split this 40 as 4 into 10. Now 4 into 10, so we can bring out 2 common, 2 outside the sign of square root. Hence it will be equal to 2 plus or minus 2 under root 10 whole divided by 2, that is 1 plus or minus under root 10. Now this is the value of x as 1 plus or minus under root 10. But it is given as a is equal to minus 2, minus 1, 0, 1 and 2. And we have got the value as x is equal to 1 plus or minus under root 10, which does not belong to a. Hence for f of x which is equal to 6, this function cannot have any pre-image for 6. We'll find out for minus 3 now. Again same procedure we will repeat for minus 3. F of x is equal to x square minus 2x minus 3. That is x square minus 2x minus 3 is equal to minus 3. So minus 3 can get cancelled. That is x square minus 2x is equal to 0. So if we take x common, then x into bracket x minus 2 is equal to 0. Hence x is equal to 0 or x is equal to 2. Now 0 and 2 both are there in set A, and hence for f of x is equal to minus 3, there are 0 and 2 both can be a pre-image for minus 3. Now we will find out pre-image for 5. F of x is equal to x square minus 2x minus 3. So x square minus 2x minus 3 is equal to 5. Now we'll bring this 5 from right hand side to left hand side. X square minus 2x minus 3 minus 5 is equal to 0. After simplification we'll get x square minus 2x minus 8 is equal to 0. Again we can factorize minus 8 so as to give summation as minus 2. So x square minus 4x plus 2x minus 8 is equal to 0. That is x into bracket x minus 4 plus 2 into bracket x minus 4 is equal to 0. Hence x minus 4 into x plus 2 is equal to 0. That is x is equal to 4 as well as x is equal to minus 2. Now minus 2 is there which is present in set A, but 4 is not there in set A. Hence for 5 pre-image is minus 2. Moving to next problem. A function f from R to R is defined by f of x is equal to x square. Determine the range of f. X for f of x is equal to 4 and y for f of y is equal to minus 1. F of x is equal to x square. Now we need to find out range of this function, as the function is defined on real numbers. Now we know that real numbers can be all the numbers which are negative numbers, 0, as well as fractions, as well as positive numbers. Now for all the negative numbers, square of all the negative numbers will be positive number. Similarly, square of all positive numbers is positive number only, and square of 0 is 0. Hence, range of this function f of x which is equal to x square is always equal to or greater than 0. That is, it will be either 0 or all the positive numbers. Now, we will find out pre-image for f of x is equal to 4. Now, f of x is equal to x square. Hence, x square is equal to 4. So, by taking square root, we can find out x is equal to plus or minus 2. Similarly, it's given as f of x is equal to x square. We need to find out pre-image for minus 1. That is, y square is equal to minus 1. So, y is equal to plus or minus under root minus 1. Now, for any real number, square of any real number cannot be negative. Hence, pre-image for this f of y is equal to minus 1 does not exist. So, ultimately y is equal to empty set, that is y is equal to 5. Moving to next problem. If f, g and h are three functions defined from R to R as follows: f of x is equal to x square, g of x is equal to sin x, and h of x is equal to x square plus 1. Find the range of each function. Now it's given as for the first function f of x is equal to x square, and this function is defined on the set of real numbers. So now, similar to previous problem, we have already seen that for all the real numbers, square will be always equal to 0 or positive numbers. Hence, range of this function will be from 0 to infinity. So, in this set, 0 will be included up to infinity. So range of this function will be under square bracket 0 up to infinity. Now g of x is equal to sin x. So domain of this sine function can be either from minus pi by 2 to pi by 2, that is from minus 90 degree to plus 90 degree. Now we know that sine minus pi by 2 is equal to minus 1 and sine pi by 2 is equal to 1, and hence range of this sine function is equal to minus 1 to plus 1, both inclusive. H of x is equal to x square plus 1. Now as we know that square of each real number is always positive except 0. Square of 0 is equal to 0, but h of x is equal to x square plus 1. So if at all x is equal to 0, still h of x will be 0 square plus 1, that is positive. Hence h of x can have all the values of all the positive values of real numbers except 0. That is, the range of this h of x will start from 1 to infinity. Moving to next problem. Express the function f from x to r given by f of x is equal to x cube plus 1 as set of order pairs where x is equal to minus 1, 0, 3, 9 and 7. Now this function is defined on the set of real numbers where f of x is equal to x cube plus 1 and domain of x is given as minus 1, 0, 3, 9 and 7. So f of 1 will be equal to minus 1 cube plus 1, that is minus 1 plus 1 is equal to 0. F of 0 will be equal to 0 cube plus 1, that is 0 plus 1 is equal to 1. F of 3 is equal to 3 cube plus 1, that is 27 plus 1 is equal to 28. F of 7 will be equal to 7 cube plus 1, that is 343 plus 1 is equal to 344. And f of 9 is equal to 9 cube plus 1, that is 729 plus 1 is equal to 730. So function f will be minus 1, 0, 0, 1, minus 1, 0, 0, 1, 328, 7, 324 and 9, 730. So range of this function will be 0, 1, 28, 344 and 730. Moving to next problem. Let A is equal to PQRS and B is equal to 1, 2, 3. Which of the following relations from A to B is not a function? R1 is equal to P1 Q2 R1 S2. R2 is equal to P1 Q1 R1 S1. R3 is equal to P1 Q2 P2 S3 and R4 is equal to P2 Q3 R2 and S1. Now we will find out for each one. R1 is equal to P1 Q2 R1 and S1. Now there are 4 elements in set A, that is P, Q, R and S, and there are 3 elements in B, that is 1, 2 and 3. Now all the elements from A have some image from set B and hence it is a function. Now for R2, P1, Q1, R1 and S1. Now here also all the elements from A have an image from B and hence it is a function. R3 is equal to P1, Q2, P2 and S3. Now in this case there are 2 images for P, that is 1 and 2, and besides there is no image for R which is given in R3 and hence it cannot be a function. That is, P is an element from A is a pre-image for 2 separate elements from B and hence it is not a function. R4 is equal to P2, Q3, R2 and S3. Now again, similar to first two problems, all the elements from A have an image from B and hence it is a function. Now we'll see few problems based on the algebra of real functions. Let f of x is equal to 2x plus 5 and g of x is equal to x square plus x. Describe f plus g, f minus g, fg and f upon g, and also find out domain in each case. Now we'll solve all these four cases one by one. F of x is equal to 2x plus 5 and g of x is equal to x square plus x. Now first one is f plus g. So f plus g is equal to f plus g of x, that is f of x plus g of x. It is equal to 2x plus 5 plus x square plus x. So after simplification we will have x square plus 3x plus 5. Now f and g, both the functions are defined on real numbers, hence domain of f plus g is also real numbers. F minus g of x is equal to f of x minus g of x, that is 2x plus 5 minus g of x. So after adjustment of the signs we will get 2x plus 5 minus x square minus x, that is minus x square plus x plus 5. Now again both f and g are defined on the set of real numbers, hence f of f minus g is also defined on the set of real numbers, hence domain is also real numbers. Now next is fg. Fg of x is equal to f of x into g of x, that is 2x plus 5 into x square plus x. After simplification we will get 2x cube plus 2x square plus 5x square plus 5x, that is 2x cube plus 7x square plus 5x. Now similar to previous two cases, domain of fg is also real numbers. And the last case is f upon g, that is f upon g of x is equal to f of x upon g of x, which is equal to 2x plus 5 upon x square plus x. Now we know that real numbers also contain 0. Now in this case this function cannot be defined if the denominator is 0. Hence domain of f upon g is all the real numbers except for the numbers where denominator is 0. So domain is real numbers except x square plus x is equal to 0. Now we can simplify x square plus x, which is not equal to 0, is x into bracket x plus 1 should not be equal to 0. That means either x should not be equal to 0 or x plus 1 should not be equal to 0, that is x should not be equal to minus 1. Hence domain of this function is all the real numbers except 0 and minus 1. So we can write the domain as r minus 0 and minus 1. Moving to next problem. If f, g and h are real functions defined by f of x is equal to under root x plus 1, g of x is equal to 1 by x, h of x is equal to 2x cube minus 3, then find the values of 2f plus g minus h of 1 and 2f plus g minus h of 0. We'll write down the given functions first. F of x is equal to under root x plus 1, g of x is equal to 1 by x and h of x is equal to 2x cube minus 3. Now f of x is equal to under root x plus 1. That means f of x can be defined only for the values of x plus 1 greater than equal to 0. That is x is greater than or equal to minus 1. So we can find out the domain as x belongs to minus 1 to infinity. Similarly, g of x is equal to 1 by x. Hence, value of x can be all the real numbers x belongs to r minus 0. H of x is equal to 2x cube minus 3. This h of x can be defined for all the real numbers. Domain of f intersection g intersection h is equal to minus 1 to infinity intersection r minus 0 intersection r. That is, domain will be equal to minus 1 to infinity minus 0, that is except 0. Now, we need to find out the value for the function 2f plus g minus h. So, first of all, we will simplify this 2f plus g minus h of x will be equal to 2f of x plus g of x minus h of x. That is 2 into bracket under root x plus 1 upon 1 by x minus 2x cube minus 3. Now, we need to find out 2f plus g minus h of 1. So, it is equal to 2 into bracket 2 square root of 1 plus 1 plus 1 upon 1 minus 2 into bracket 1 cube minus 3. That is 2 under root 2 plus 1 plus 1. That is 2 under root 2 plus 2. Now, for 2f plus g minus h of 0, we need not find out this value because this function doesn't exist for 0. As we have already calculated that domain of this function is minus 1 to infinity except 0. Moving to next problem. Let fg is defined on r to r be defined respectively by f of x is equal to x plus 1, g of x is equal to 2x minus 3. Find f plus g, f minus g and f upon g. Now, f of x is equal to x plus 1, g of x is equal to 2x minus 3. F plus g is equal to f plus g of x is equal to f of x plus g of x. That is x plus 1 plus 2x minus 3. That is equal to 3x minus 2. Similarly, f minus g is equal to f minus g of x. That is f of x minus g of x. That is x plus 1 minus 2x minus 3. So, signs will be reversed, that is minus 2x plus 3. Hence, it is equal to minus x plus 4. And f upon g is equal to f of x upon g of x, that is x plus 1 upon 2x minus 3. Now, this function can be defined only for 2x minus 3 is not equal to 0, that is 2x is not equal to 0, that is x is not equal to 3 by 2. Moving to next problem. Let f of x is equal to x square and g of x is equal to 2x plus 1 be two real functions. Find f plus g of x, f minus g of x, fg of x and f by g of x. Now, f of x is equal to x square, g of x is equal to 2x minus 1 is given. Now, f plus g of x is equal to f of x plus g of x, that is x square plus 2x plus 1. Similarly, f minus g of x is equal to f of x minus g of x, that is x square minus 2x minus 1. Fg of x is equal to f of x into g of x, that is x square into bracket 2x plus 1, that is 2x cube plus x square. And now, f upon g of x is equal to f of x upon g of x, that is x square upon 2x plus 1. Now, this function will be true only for 2x plus 1 is not equal to 0, that is 2x is not equal to minus 1, ultimately x is not equal to minus 1 by 2. Now we'll see few problems based on types of functions. Which of the following functions from a to b are 1, 1 and onto? f1 is equal to 1, 3, 2, 5, 3, 7, whereas a is equal to 1, 2, 3 and b is equal to 3, 5, 7. f2 is equal to 2a, 3b and 4c, whereas a is equal to 2, 3, 4 and b is equal to abc. f3 is equal to ax, bx, cz and dz, whereas a is equal to abcd and b is equal to xyz. Now f1 is equal to 1, 3, 2, 5 and 3, 7, whereas a is equal to 1, 2, 3 and b is equal to 3, 5, 7. Now in this case, if we observe, 1 is related to 3, 2 is related to 5 and 3 is related to 7. That means the image of distinct elements of A under F are distinct in B. Hence F1 is 1, 1 function. Similarly, every element of B is the image of some or the other element of A under F. Hence F1 is onto function also. F2 is equal to 2a, 3b and 4c, whereas a is equal to 2, 3, 4 and b is equal to abc. Now here if we observe, this 2 is related to a, 3 is related to b and 4 is related to c. Now exactly this scenario is exactly similar to previous problem. That is, the image of distinct elements of A under F are distinct in B. Hence F2 is 1, 1 function and every element of B is the image of some element of A under F, and hence F2 is onto function also. F3 is equal to AX, BX, CZ and DZ, whereas A is equal to ABCD and B is equal to XYZ. Now this A is related to X, B is also related to X, C is related to Z and D is also related to Z. So we don't have any pre-image for Y. Now the image of distinct elements of A under F are not distinct. That is, A is also related to X and B is also related to X. Hence it is a many one function and it is not 1, 1 function. Similarly, from B, X and Z have some pre-image, but Y does not have any pre-image and hence it is not onto function also. Moving to next problem. Let A is equal to -1, 0, 1 and F is equal to x square such that x belongs to A. Show that F from A to A is neither 1, 1 nor onto. Now A is equal to -1, 0, 1 and F is equal to x square such that x belongs to A. That is, f of x is equal to x square. Now we will calculate value of f of x for each element of the domain A. Now domain of A is -1, 0 and 1. So f of -1 is equal to -1 square is 1. F of 0 is 0 square, that is 0. And f of 1 is equal to 1. So function f will be -1, 1. So relation f is equal to 0, 0 and 1 and 1. Now the image of distinct elements of x are not distinct. That is, -1 is related to 1 and similarly 1 is also related to 1. So it is not 1, 1 function. Similarly, if -1, 0 and 1, all these three elements are there in f of x, then -1 does not have any pre-image from set A, hence f is not onto function also. So hence we can prove that a is neither 1 function nor onto function. Classify the following functions as injective, surjection. Classify the following functions as injection, surjection or bijection. Any function which is 1 function is called as injection. Any onto function is called as surjection, and in any function which is 1 as well as onto is called as bijection. Now we'll see each function one by one. F is defined on the set of natural numbers given by f of x is equal to x square. Now square of every natural number is always unique, but every natural number is not square of some natural number. For example, 5. 5 is a natural number, but it is not a square of any other natural number. Hence, this function f of x is equal to x square is 1 function, but it is not onto, and hence it is injection. F is defined on integers given as f of x is equal to x square. Now, in previous case, the square function was defined on natural number. So every natural number has some or the other square. But now in this case, the domain of this function is integers. So minus 2 square is also equal to 4 and plus 2 square is also equal to 4. Hence, this function cannot be onto function as well as it cannot be 1 function also, because negative and positive integers will have the same integer as its square. Besides, not every integer is square of some integer. Hence, this function is neither 1 function nor onto function. Next, the function f is defined on the set of natural numbers such as f of x is equal to x cube. Now, similar to the first case, cube of every natural number is unique, but every natural number is not cube of some natural number, that is 2. 2 is a natural number, but it is not a cube of any natural number. Hence, this function is also 1 function but not onto, hence it is injection. Next, f is defined on set of real numbers such as f of x is equal to sin x. Now, let's suppose x is equal to 0. We know that sin 0 is equal to 0. Similarly, if we take x is equal to 180, then we know that sin 180 is also equal to 0. Hence, this sin x function is not 1 to. This sin x function is neither 1 nor onto function. And the last case is f of x is equal to x cube plus 1, and it is defined on the set of real numbers. Now, as we have seen, for all real numbers, x square is neither onto function nor 1 function. Similarly, for all the real numbers, f of x is equal to x cube will also not be 1 function, and it won't be onto function also. But f of x is equal to x cube plus 1. Now, we will have some different result if we add 1 to negative numbers as well as if we add 1 to positive numbers. Hence, for all the real numbers, f of x is equal to x cube plus 1 will be 1 function and not onto function. Moving to next problem. Find g of f and f of g, where f is defined on real numbers and g is also defined on the set of real numbers such as f of x is equal to 2x plus 3 and g of x is equal to x square plus 5. Now, f of x is equal to 2x plus 3 and g of x is equal to x square plus 5. First of all, we will calculate g of f. So, g of f of x is equal to g of 2x plus 3. Now, as we know that g of x is equal to x square plus 5. So, we will put 2x plus 5 in place of x under g of x. Hence g of 2x plus 3 is equal to 2x plus 3 bracket square plus 5, that is 4x square plus 12x plus 9 plus 5, which is equal to 4x square plus 12x plus 14. Similarly, we will calculate f of g. Now, f of g of x is equal to f of x square plus 5, that is 2 into bracket x square plus 5 plus 3 is equal to 2x square plus 10 plus 3, that is 2x square plus 13. Find g of f and f of g when f is defined on real numbers and g is also defined on real numbers, such as f of x is equal to 2x plus x square and g of x is equal to x cube. Now, f of x is equal to 2x plus x square and g of x is equal to x cube. First of all, we will find out g of x, that is g of f of x. So, g of 2x plus x square, which is equal to 2x plus x square bracket cube. Similarly, we will calculate f of g, that is f of g of x. Now, what is g of x? G of x is x cube. So, f of x cube. Now, f of x is equal to 2x plus x square. Hence, f of x cube is equal to 2 into bracket x cube plus x square, x cube, and square of x cube is x raised to 6. Hence, 2x cube plus x raised to 6. 2x cube plus x raised to 6. Moving to next problem. Find g of f and f of g when f of f is defined on real numbers and g is also defined on real numbers, such as f of x is equal to x square plus 8 and g of x is equal to 3x cube plus 1. We will write the given functions. F of x is equal to x square plus 8 and g of x is equal to 3x cube plus 1. Now, initially we will find out g of x, that is g of f of x. So, g of x square plus 8. Now, g of x is equal to 3x cube plus 1. So, we will put x square plus 8 in place of x. So, we have 3 into bracket x square plus 8 bracket cube plus 1. You can further simplify or you can keep it as it is. Now, f of g is equal to f of g of x, that is f of 3x cube plus 1, that is 3x cube plus 1 bracket square plus 8 as it is. So, 9x raised to 6 plus 6x cube plus 1 and plus 8, that is 9x raised to 6 plus 6x cube plus 9. Moving to next problem. Find g of x and f of g when f is defined on real numbers and g is defined on real numbers, such as f of x is equal to x and g of x is also equal to x. Now, this is very simple problem. F of x is equal to x and g of x is also equal to x. So, g of f is equal to g of f of x, that is g of x, and g of x is nothing but x. Similarly, f of g is equal to f of g of x, that is f of x, and f of x is nothing but x. Hence, g of f is also equal to f and f of g is also equal to x. Moving to next problem. Find g of f and f of g when f is defined on real numbers and g is defined on real numbers. F of x is equal to x square plus 2x minus 3 and g of x is equal to 3x minus 4. We will write the given functions first. F of x is equal to x square minus 2x minus 3 and g of x is equal to 3x minus 4. Now, g of f is equal to g of f of x, that is g of x square minus 2x minus 3. Now, what is g of x? G of x is equal to 3 into x minus 4. Hence, is equal to 3 into bracket x square plus 2x minus 3 minus 4 as it is. So, 3x square plus 6x minus 9 minus 4, that is 3x square plus 6x minus 30. Similarly, f of g is equal to f of g of x, that is f of 3x minus 4. Now, f of x is equal to x square plus 2x minus 3. Hence, f of 3x minus 4 is equal to 3x minus 4 bracket square plus 2 into bracket 3x minus 4 minus 3. Upon simplification, we can have 9x square minus 24x plus 16 plus 6x minus 8 minus 3 as it is. That is 9x square minus 18x plus 5. Find g of f and f of g when f is defined on real numbers and g is defined on real numbers, such as f of x is equal to 8x cube and g of x is equal to x raised to 1 by 3. Now, f of x is equal to 8x cube and g of x is equal to x raised to 1 by 3. So, first of all, we will find out g of f, that is g of f of x. Now, what is f of x? F of x is 8x cube. Hence, g of 8x cube. But what is g of x? G of x is x raised to 1 by 3. Hence, 8x cube raised to 1 by 3. So, cube root of 8x cube will give you the value as 2x. Similarly, f of g is equal to f of g of x, that is f of x raised to 1 by 3. Now, what is f of x? F of x is equal to 8 into x cube. So, f of x raised to 1 by 3 will be equal to 8 as it is and x raised to 1 by 3, that is cube. So, cube of x raised to 1 by 3 will be equal to x. Hence, g of f is equal to 2x and f of g is equal to 8x. Now, we will see few problems based on the inverse of functions. Find f inverse if it exists on f from a to b, where a is equal to 0, minus 1, minus 3, 2 and b is equal to minus 9, minus 3, 0 and 6, and f of x is equal to 3x. Now, it is given as f is defined from a to b, where a is equal to 0, minus 1, minus 3, 2 and b is equal to minus 9, minus 3, 0 and 6, and f of x is equal to 3 of x. So, first of all, we will calculate the value of f of x for all the values of a. Now, f of x is equal to 3x. Hence, f of 0 will be equal to 3 into 0, that is 0. F of minus 1 will be equal to 3 into minus 1, that is minus 3. F of minus 3 will be equal to 3 into minus 3, that is minus 9, and f of 2 will be equal to 3 into 2, which is equal to 6. Now, if you observe, set B is given as minus 9, minus 3, 0 and 6. So, we can define relation R such as 0, 0, minus 1, minus 3, minus 3, minus 9 and 2, 6, because all the values of f of x exist in set B. Hence, R is equal to 0, 0, minus 1, minus 3, minus 3, minus 9 and 2, 6. And hence, R inverse is reverse of pairs in R, that is 0, 0, minus 3, minus 1, minus 9, minus 3 and 6, 2. Moving to next problem. State with reasons whether the following functions have inverse. F is equal to 1, 2, 3, 4 related to 10 with f is equal to 110, 210, 310 and 410. Now, in this case, f is given as 1 is related to 10, 2 is related to 10, 3 is also related to 10 and 4 is also related to 10. So, f from 1 to 4 is related to 10. That means, if at all f inverse exists, then 10 would be related to 1, 2, 3 and 4, which is not a function. That is, in this case f is a many one function and hence inverse doesn't exist. Moving to next problem. State with reasons whether the following functions have inverse. G is equal to 5, 6, 7, 8 related to 1, 2, 3, 4 with G is equal to 5, 4, 6, 3, 7, 4 and 8, 2. Now it's given as G is equal to 5, 4, 6, 3, 7, 4 and 8, 2. That is, domain of G is 5, 6, 7, 8 and range of G is 1, 2, 3 and 4. Now in this case 5 is related to 4, 6 is related to 3, 7 is also related to 4. So if at all G inverse exists, then 4 would be related to 5 and 7, which is not a function because G is a many one function and hence G inverse does not exist. State with reason where following functions have inverse. H is equal to 2, 3, 4, 5 which is related to 7, 9, 11, 13 with H is equal to 2, 7, 3, 9, 4, 11 and 5, 13. Now H is equal to 2, 7, 3, 9, 4, 11, 5, 13. So in this case H is a bijection, hence inverse exists and H inverse is equal to 7, 2, 9, 3, 11, 4 and 13, 5. If A is equal to 1, 2, 3, 4 and B is equal to A, B, C, D, define any 4 bijections from A to B and also give their inverse functions. Now you can have any possible combination of A and B where the function has to be 1, 1 and onto. So for example, F1 is equal to A1, 2B. F1 is equal to 1A, 2B, 3C and 4D. So F inverse is equal to A1, B2, C3 and D4. Similarly, F2 can be 1A, 2C, 3B and 4D. So F2 inverse is equal to A1, C2, B3 and D4. F3 can be 1D, 3B, 2A, 4C and F3 inverse will be D1, B3, A2 and C4. F4 is 1D, 3A, 2B and 4C and F4 inverse is D1, A3, B2 and C4. Basically you just have to take care while defining the functions F1, F2, F3 and F4 that all these 4 functions have to be 1, 1 and onto. Then only you can find out the inverse. With this we have covered practice problems on functions, algebra of functions and types of relations. Thank you. If at all you have any doubt in any of the concept on functions, relations, types of functions, do let me know in comments. We will try to cover those problems in upcoming videos. Thank you.